multiples of pi by 6 and pi by 4. We're going to learn about the sine, cosine and tangent of some standard angles. These need to be learned. Together with our knowledge of the unit circle, we can find the sine, cosine and tangent for any multiple of pi by 6 or pi by 4 in exact form once we know these. So for the first one, we're going to look at an isosceles right-angled triangle. So it's a right-angled triangle, and we said it was isosceles. I'm going to say this side is of length 1, and so is this one. Then using Pythagoras' theorem, the length of the hypotenuse would be the square root of 1 squared plus 1 squared, so it would be root 2. Now, if this is an isosceles right-angled triangle, this angle must be 45 degrees. Or, since we're working in radians, that's pi by 4 radians. So the sine of pi by 4 radians, or 45 degrees, would be equal to the opposite over the hypotenuse, so 1 over root 2. Remember, that's equal to root 2 over 2, although for some reason people often leave this one here. The cosine of pi by 4 is the adjacent over the hypotenuse, which is also 1 over root 2. And the tangent of pi by 4 is equal to the opposite over the adjacent, so 1 divided by 1, which is just 1. Now the other triangle we look at when we do this is an equilateral triangle. And we say that the side length is 2. And then what we do here is we drop down a perpendicular just here so that we form a right-angled triangle. So this side now is of length 1, this is 2, and if we just consider this right-angled triangle, this side here, using Pythagoras' theorem, will be the square root of 2 squared take away 1 squared, so the height of the triangle here is root 3. Now, it was an equilateral triangle, so this angle here is 60 degrees, or pi by 3 radians. This angle here, having been a 60-degree angle split in half, is 30 degrees, which is pi by 6 radians. So the sine of pi by 6 would be equal to the opposite over the hypotenuse, so it's a half. The cosine of pi by 6 is the adjacent over the hypotenuse, so that's root 3 over 2. And the tangent of pi by 6 is the opposite divided by the adjacent, so that's 1 over root 3. And of course we could write that as root 3 over 3, but it's often left just here. Now let's think about the pi by 3. The sine of pi by 3 for this angle, this one now is the opposite, so that's root 3 over 2. The cosine of pi by 3, adjacent over hypotenuse, that one is a half, and the tangent of pi by 3 is opposite over adjacent, so root 3 over 1, which is just root 3. It's really, really important that you learn all of these standard angles.